Hi, my name is Shawn Gothra and I am a grade 12 student at Bill Crothers Secondary School. I am here to provide a step-by-step explanation on a grade 12 advanced function question. I will instruct you through the question and guide you with all the components necessary in finding the solution. My question is from page 214, section 4.2, question number 10. It states, which of the following inequalities has a solution? Explain. It is evident that this question is a linear inequality due to the inequality symbol. This question is asking us to find either 3 minus x greater than x minus 3 but less than x minus 5 has a solution, or 3 minus x less than x minus 3 but greater than x minus 5 has a solution. This question is from Unit 2, Polynomial Functions. Now, let's take a closer look at solving linear inequalities algebraically. Solving linear inequalities algebraically is almost exactly like solving linear equations. You want to isolate for x and get it by itself to one side. To get x by itself, depending on the question, you need to either use the addition, subtraction, multiplication, or division property. Some questions will need more than one property to solve. The subtraction property of an inequality states if the constant is being added to a variable, then subtracting the constant from both sides will get x by itself. I've shown how this property works in the example below. We can check this solution because any number greater or equal to 3 plugged back for x into the equation will give us a number greater or equal to 8. The addition property of an inequality states if the constant is being subtracted from the variable, then adding the constant to both sides will get x by itself. I have shown how the addition property works in the example below. We get a solution of x less than 10, and we can check this solution because any number less than 10 plugged back in for x in the inequality will give a number less than 6. The addition and subtraction property also states if you have a variable on each side of the inequality, to bring it to one side, you either use the addition or subtraction property. I've shown an addition example and a subtraction example down below. The division property of an inequality states if a positive constant is being multiplied with the variable, then you divide out the constant from both sides to get x by itself. And the division property is shown in the example below. If a negative constant is being multiplied with the variable, you still divide out the constant from both sides, but you reverse the inequality. And this is shown in the example below. The multiplication property of an inequality states if you multiply a positive number to each part to get x by itself, the inequalities will not change. In the example below, the inequalities stay the same because we were multiplying each part by a positive number. But if you multiply a negative number to each part to isolate for x, then the inequalities will flip. In the example below, since we multiplied each part by negative half, the inequalities will flip. Now that we know all the components of linear inequalities, let's solve the question. Let's take a quick look back at the question. Which of the following inequalities has a solution? Explain. So let's solve the first inequality. The first inequality is 3 minus x greater than x minus 3 but less than x minus 5. Let's break down the question into two parts. First, let's solve x minus 3 less than 3 minus x on the left side. Since 3 is being subtracted from the variable, and to get x by itself, we use the addition property. And this gives us x minus 3 plus 3 less than 3 minus x plus 3. The 3's cancel out on the left side and we are left with x less than negative x plus 6. Since we have a negative x on the right side, to get rid of it, we also use the addition property. So then we get x plus x less than negative x plus 6. The x's on the right side cancel out and we are left with 2x less than 6. Now let's go to the right side of the page and look at the other half of the inequality, 3 minus x less than x minus 5. Since we're trying to get x by itself on the left side, to get rid of the 3, we use the subtraction property. So we are left with 3 minus x minus 3 less than x minus 5 minus 3. The 3's cancel out on the left side and we are left with negative x less than x minus 8. Since we're trying to get the x on the left side, we use the subtraction property to get rid of the x on the right side. So now we get negative x minus x less than x minus 8 minus x. The x's on the right side cancel out and we are left with negative 2x less than negative 8. The x should always be positive, so we use a multiplication property and multiply each part by negative 1 to get the negative 2x positive. And the multiplication property states when we are multiplying each part by a negative number, we have to flip the inequality. So after multiplying negative 2x times negative 1 and negative 8 times negative 1, we get 2x greater than 8. Now we use the division property to get x by itself, so we divide out the constant of 2 from both sides, and now we're left with x greater than 4. So our final solution of combining both ranges will give us x less than 3 and greater than 4. Now let's solve the second inequality, 3 minus x less than x minus 3 but greater than x minus 5. Let's also break down this question into two parts. First, let's solve x minus 3 greater than 3 minus x on the left side. Since 3 is being subtracted from the variable, we use the addition property to get rid of the 3 and get x by itself. So it becomes x minus 3 plus 3 greater than 3 minus x plus 3. And this gives us x greater than negative x plus 6. Since we want to get x on the left side, we have to get rid of the x on the right side. So we use the addition property and add x to both sides. So we're left with x plus x greater than negative x plus 6 plus x. And the x's on the right side cancel out, so we are left with 2x greater than 6. Since the constant of 2 is being multiplied by a variable, we can use the division property and divide out the 2 from both sides. So here we are left with x greater than 3. Now let's look at the other part of the inequality on the right hand side of the page, 3 minus x greater than x minus 5. Since we want to get x by itself on the left side and 3 is positive on the left side, we have to use the subtraction property and subtract 3 from both sides. So we get 3 minus x minus 3 greater than x minus 5 minus 3. And this gives us negative x greater than x minus 8. Now we want to get x by itself on the left side, so to get rid of the x on the right side, we have to use the subtraction property and subtract x from both sides. So we get negative x minus x greater than x minus 8 minus x. The x's on the right side cancel out, and this gives us negative 2x greater than negative 8. We never want x to be negative, so in this case, we use a multiplication property and multiply each part by negative 1 to get rid of the negative in front of the 2x. Since we're multiplying by a negative number, we have to flip the inequality. So we get negative 2x times negative 1 less than negative 8 times negative 1. And this gives us 2x less than 8. Now we can just use the division property and divide out the 2 from each side to isolate for x, and this gives us x less than 4. Now we can combine both ranges, and this gives us x greater than 3 and less than 4, and this is our solution for this inequality. Now let's check our solutions. Let's check the solution for the first inequality, 3 minus x greater than x minus 3 but less than x minus 5, which had a solution of x less than 3 but greater than 4. This solution is false because x values cannot be less than 3 and greater than 4 at the same time. In the graph below, I've drawn the lines for 3 minus x, x minus 3, and x minus 5, which are stated in the inequality. This graph shows us that there are no x values that show 3 minus x being greater than x minus 3 and less than x minus 5 at the same time. Let's look at the solution for the second inequality of 3 minus x less than x minus 3 but greater than x minus 5. This inequality had a solution of x greater than 3 but less than 4. This solution is true because x values can be greater than 3 and less than 4 at the same time. In the graph below, I've drawn the lines for 3 minus x minus 3, and x minus 5 again. This graph shows us that there are x values that show 3 minus x being greater than x minus 5 and less than x minus 3 at the same time. Let's check the solutions algebraically. Let's look at the solutions for the first inequality on the left side. If we test x equals to 10, we get a solution of negative 7 greater than 7 but less than 5. This statement is not true because 7 is greater than negative 7. Let's test x equals to 2. Testing x equals to 2, we get a solution of 1 greater than negative 1 but less than negative 3. This statement is also not true because 1 is greater than negative 3. This inequality has no solutions because any number greater than 4 or less than 3 will give a false statement. Now let's look at the solution for the second inequality on the right side. If we test x equals to 3.5, we get a solution of negative 0.5 less than 0.5 and greater than 1.5. This statement is true because negative 0.5 is less than 0.5 and also it's greater than negative 1.5. We can also test x equals to 3.75. The solution we get is negative 0.75 less than 0.75 and greater than negative 1.25. This statement is also true because negative 0.75 is less than 0.5 and negative 0.5 is greater than negative 1.25. This inequality has a solution of x being greater than 3 and less than 4 because any number greater than 3 and less than 4 will hold this inequality true. In short, the first inequality does not have a solution, but the second inequality does have a solution. A career where this type of problem would be solved is a math teacher. Thanks for watching.